Hello and welcome to the latest dose of science news from New Scientist. I'm Penny Sarte, joined again today by Rowan Hooper. Hello.
Season's greetings to you.
And to you. Now, Rowan, don't you find often at this time of year, everyone's written up their list of the biggest science findings of the year. We're all good to go.
And then a really big one comes along.
And then a really big one comes along.
Yeah.
And so this year we've got Google. They've just published a big Nature paper about a new quantum chip they're calling Willow, which is nice because they're continuing the tree theme. Always nice to see. It's at the heart of their new quantum computer, and in the paper the Google team is claiming to have pulled ahead in the race to build machines that can beat even the world's best conventional supercomputers at certain tasks, quantum supremacy as it's known. This is potentially a big deal, so we're going to get into what it means, and we're also in this show going to be talking about ways to keep your brain young, which we may well need after we've done all that thinking about quantum computers.
I need it now, let alone that. But yeah, let's start with quantum stuff. As you say, the prize is what's called quantum supremacy, and that's when a quantum computer can beat a classical computer. And there's been a to and fro, a race between quantum and classical computers over the last few years, and now with this new Willow one, Google say quantum's back in the lead. News editor Jacob Ahrens here, because thank God someone knows about this to talk about. Can you walk us through it, please, Jacob?
Yes. First, I'll give you a quick recap of what a quantum computer actually is. So a normal computer works in the binary bits of zeros and ones, but a quantum computer, thanks to the weird world of quantum mechanics, can exist in a state of 0 and 1 at the same time with qubits or quantum bits. And it's this ability that means quantum computers can theoretically outperform conventional computers on certain tasks. Certain is the important word there, of which I'll come back to. So in this case, Google's previous Sycamore quantum computer had 67 qubits, while the new Willow has been upgraded to 105. And ideally, these larger quantum computers should be more powerful. But as the sort of scale of quantum computers has grown, researchers have found that it's harder for larger devices to retain their quantumness. So Willow is particularly good at preserving its quantumness better than previous chips. And to test this, Google uses a specific benchmarking task called RCS that involves verifying that a sample of numbers output by a program on the chip has a random as distribution as possible. And Google says that Willow has done its RCS task in 5 minutes, while even the best supercomputer in the world would take 10 septillion years, which doesn't sound like a real number, but is. And that's more than the age of the universe squared.
Yeah, I mean, it's just an absurd number, isn't it? It did make me wonder if that means other calculations happening in other universes. Otherwise, it's impossible. Well, we'll get to the multiverse aspect of it later, as I know you're very keen on it.
Yes, I mean, it's a very impressive number, but it's important to remember what I said about quantum computers being good at certain tasks. And the RCS benchmarking problem essentially involves simulating the behavior of a quantum computer on a
loading the dice a little bit, yeah.
So you can see that there's kind of the home advantage for the Willow chip here. And the problem itself has no practical use, so being able to do this problem doesn't mean that we're suddenly able to solve climate change or have incredible AI or anything like that. So so even though we've got these huge numbers that sound really, really impressive, actually what's more important is the work that Google has done on error rates for its chip. So that's the sort of keeping the quantumness.
Yeah. Okay. So I managed to get that much out of it. And I heard Julian Kelly, he's the director of quantum hardware. It's quite a cool title, isn't it, at Google. And here he is talking about that point, about what Willow can do.
Our logical qubits now operate below the critical quantum error correction threshold, a long sought-after goal for the quantum computing field since the theory was discovered in the 90s. And we've achieved it for the first time with Willow. Errors are exponentially suppressed in our logical qubits, as error rates are halved each time we add physical qubits in scale from distance 3 to 5 to 7 surface codes. Additionally, our logical qubit lifetimes are now much longer than all of the lifetimes of the physical qubits that compose them. This means that even as we make our quantum chips larger and more complex by adding more qubits, we can use quantum error correction to actually improve their accuracy.
Okay, so that was the key point, isn't it? He's talking about the more qubits you add, the more they reduce errors. So let's just dig into that a bit more.
Yeah, so the important phrase that he was using there is logical qubits. So you have your physical qubits, which are literally the physical bits of the computer used to store information. You can then group those together to create what's called a logical qubit, and this means that errors in one can be sort of corrected by errors in another, and they work together better. So that means you sort of sacrifice some of the qubits that you've got to serve as error correcting qubits. Now, the problem with this, and it's something that people have been wrestling with for a few years now, is that the technique you use for correcting errors itself introduces more errors, which is obviously not what you want. But Google has now finally reached what they call the threshold, which is that even though they are still introducing errors as they correct errors, the net effect is to reduce errors, and as you scale it up, those errors reduce further. So that's really promising if you want to build a large-scale quantum computer.
Yeah, so forget this septillion years thing. It's the error correction that is why this is a big deal.
Yeah, and I'll just note that we did actually report on this back in September.
Of course we did.
So all your latest quantum news
we've already
come to New Scientist.
Now, look, I do have to talk about the multiverse bit, the many worlds hypothesis, and it's not just me being, gratuitous here. Hart McNevin, he's the founder and lead of Google Quantum AI. In the press release about Willow, he talked about that benchmark performance. It takes 10 to the 25 years. Or it would take a supercomputer 10 to the 25 years to do this, and Willow's better. He said that, and then he said this. And remember, this is the guy who's from Google's head of quantum AI. He said, "This mind-boggling number exceeds known timescales in physics and vastly exceeds the age of the universe." Fine. It lends credence to the notion that quantum computation occurs in many parallel universes, in line with the idea that we live in a multiverse, a prediction first made by David Deutsch. Quite surprising. What did you make of that, Jacob?
Yeah, so my initial reaction to seeing this was probably not suitable for a family-friendly podcast. I mean, we know that quantum computers work differently to regular computers. We already knew that before we even built one. The fact that they're now doing this doesn't sort of change anything either way about the sort of philosophy of quantum physics, right, and whether that involves the multiverse or not. And the sort of saying it exceeds the timescale of the universe is just a big distraction. And I think, the consensus from people outside of Google is that what Hart McNevin is saying here is basically complete nonsense.
Okay. So I should say, if you've not heard of David Deutsch, He's famous for laying the theoretical, mathematical foundations for the quantum theory of computation. And since that press release mentioned him by name, I reached out to him to ask him what he made of that. And, I've had some interaction with him in the past, and he's always been good value. Once he told me that the evidence that we live in a multiverse is at least as strong as the evidence that there were dinosaurs once on Earth.
No, I will not allow that.
That is also not true.
Yeah, but, I know, but what a fantastic quote. So, I thought I'd get a good response from him. But when I asked him what he made of his name coming up in the Willow press release, he said he was the wrong person to ask. So I think that response is evidence that we're in the multiverse, because I've ended up in a branch where David Deutsch won't comment on himself.
On himself.
Yeah. So, but what I did do is ask another quantum dude about this. Is Vladko Vedral. He's professor of quantum information science at Oxford. And listen to this, Jacob, and everyone else.
Google's latest quantum chip, Willow, is certainly a milestone, as it achieved the error rate for logical qubits below the required threshold. And most importantly, is the largest demonstration of this kind so far. This clearly could pave the path to scalability. However, I would like to see two further demonstrations from Google. One is an implementation of a practically relevant quantum computation, such as, say, Grover's search algorithm. But even more interestingly for a physicist, it'd be great to implement a quantum measurement protocol in which one part of the chip observes another of its own parts. This would demonstrate what one might call quantum introspection. It would require Willow to be prepared in a maximally entangled state of all of its logical qubits, the so-called GHZ state. This, in my view, would provide further evidence for the picture of quantum mechanics advocated originally by Schrödinger and Everett, and more recently by Deutsch, in which we have to acknowledge the existence of multiple simultaneously existing realities, all within one overarching quantum reality.
That's exciting, right?
Yeah, I mean, it really does come down to philosophy still. I think it's very, very hard to say, yes, this experiment. I think you're going to struggle to find someone who doesn't believe it, who is then going to be convinced by one single experiment.
Yeah. Well, what I do have to say is quantum introspection. That's going to be a New Scientist cover line before long, right? I want to read that story.
Yeah, all right. Can I just bring us back down to earth? Because I thought one of the really interesting discussions in the newsroom this week was the end goal of this isn't that we're all going to be sitting at quantum laptops, is it? So even if they do make quantum computing useful, this is a future where there's going to be all different kinds of computers that are working together in different ways. Am I getting that right?
Yeah, so the thing that I always have to keep repeating is that quantum computers are only useful for certain tasks. So Vlatko just mentioned Grover's algorithm, which is one of the sort of classics perhaps the wrong word, one of the original quantum algorithms that was developed before we even had a computer to run it on. And that has been mathematically demonstrated to show that it could do searching, so looking through a database faster than a classical computer could do it. We've never seen an actual demonstration of Grover's algorithm that exceeds what a supercomputer could do. So something like that would be really, really exciting to see.
Okay, right. If your brain is feeling worn out after thinking about that, or at the end of the year, because I feel about 12 years older rather than 12 months older than the start of the year, we now have this story all about a new finding on brain aging.
Yeah, I've always been interested in this, obviously. And I remember a few years ago, I interviewed some centenarians. It's a real privilege also, by the way, to meet and talk to people that old about their lives. And what was striking was how sprightly they were and, you know, how alert their brain obviously is. It does feel like there's something in people who reach 100 years or reach great age, something about them that preserves their brain function. And the billion-dollar question is, what is that thing?
Yes, put it in a bottle and hand it over.
Put it in my veins. Well, we're not going to give you that in today's show, just to manage expectations. But there's a paper out this week about brain aging, and I thought we'd go over that a bit because it does start to grope towards an idea about how to preserve brain function.
Yeah, so this is a paper that identifies 13 proteins in the blood that could reveal the age of your brain. So this is that idea that, you know, on average, we're the age that you are, but potentially you might have a brain or a heart or a liver that is as good as a 20-year-old or as bad as a 50-year-old, even if you're neither of those ages. Yeah. So Carissa Wong, you're here to tell us all about it. Carissa, take us through what they found in this study.
Yeah, so there are two steps to this, really. So the researchers from Fudan University in China looked at MRI brain scan data from around 11,000 people. And essentially, these people were aged from 50 to 80. And so by looking at these images, they could essentially see the physical structure of their brain. And they took these 70% of these scans and got an AI model to be able to predict how old the participants were based on features of these brain images. So that's things like the size of brain regions and how well connected they were to each other.
So this model then could work out how old a brain was by looking at sort of common structures in the brains of older people.
Yeah, essentially. And once the AI model was trained, it could predict the age of 30% of the participants that it hadn't seen before with an accuracy of within 2.7 years of their actual age.
Wow.
Yeah, that's really impressive, isn't it? And just not to go on about my own anecdotes again, although I am about to.
Rowan's story time.
I'm sorry, but I remember being in a trial and being in an MRI scanner and having to do empathy tests it was, and you could see your brain actively, maybe that's the empathy area, and it was really quite spooky seeing what's going on in your brain, and the idea that like you're seeing now in this piece, that you can now tell your age from these brain scans as well. That's
That's pretty cool.
It is.
Yeah. So they were able to look at these scans then and say, okay, within a certain amount of accuracy, this is probably the age of the brain. What next?
So next they took advantage of the fact that there was a separate group of people who had their brain scans also for the UK Biobank. And these people had also donated blood samples at the time around when they were imaged, and they were aged around 63 years old on average. But since people age at different rates, you can find a difference between the age of the brain according to the AI and the actual age of that person.
Right, so the mismatch between your actual age and the age that the AI gives you based on what your brain looks like is a measure of like how well or how badly your brain is aging.
Essentially, yes. So they call this the brain age gap, and the higher the AI predicted age is relative to someone's actual age, the faster their brain is aging. But the other thing here, as I mentioned, is that we also have blood samples. So by looking at the blood, the team could pinpoint 8 proteins that seemed to strongly increase and 5 proteins that seemed to decrease with a larger brain gap.
So that's exciting, isn't it? Because we can't stick everyone like Rowan in a brain scanner, but it is a lot easier to look at people's blood, isn't it? So I can see why that's exciting. But correlation doesn't equal causation. Like, just because some proteins are a bit different in the blood, what does that really sort of indicate?
Yeah, that's a good point. So the team did dig a little into whether there might be a causal link here. So they looked at data from previous studies, and they found that, yes, these proteins are produced by brain cells, and also their levels do seem to link to the risk of some brain conditions like dementia and stroke. So this does suggest that potentially blood tests for these proteins could indicate how quickly someone's brain is aging and potentially even hint at their risk of diseases. I spoke to neuroscientist Nicholas Seyfried about this, and he had a good quote. He said, "These markers could be the canary in the coal mine to tell you, hey, look, let's start intervening now to slow your brain aging while you've still got time." But for this to be useful, we need to know that these proteins can be altered by lifestyle changes. There's no point being told, oh, your brain's aging really fast because of these proteins, but not having a way to tell if you can change that outcome. So, yeah, you want to be able to say to someone, if you run this much or you lose this much weight or you change your diet in a certain way, that you can modify those levels to bring them back to the normal range and hopefully benefit your brain health. I will say the research was also mostly carried out on white, wealthy people, however, so further research is needed to see whether the results apply to other populations of more diverse ethnicities and income levels. To your point, Penny, about causation, the team now hopes to carry out research in animals to pinpoint how the 13 proteins actually play a role in the brain. For instance, the researchers told me they might test how disrupting levels of these proteins in animals might change their animals' cognition or even the development of neurodegenerative conditions. So they hope that in the next couple of decades, this could open up ways to target those proteins to slow aging or disease.
Yeah, because I guess if they're just correlates, they could still be useful because they tell us something about the state of health of the brain. But if they're actually like causally involved in brain aging, then that's a whole bunch of new targets we could try to treat to actively improve things, right?
Yeah, exactly.
Asking for a friend, if you can't wait to find this information about how to stop your brain aging, Carissa, what can you do?
Yeah, so there is something you can do. You don't have to wait decades, because I've been reporting on another story where neuroscientists have been looking at ways that you can reduce aging of the brain, and they've pinpointed 8 sort of interventions that you can make, and these include the usual healthy habits. So that's things like exercising regularly, in particular getting at least 150 minutes of moderate exercise like brisk walking a week, or 75 minutes of vigorous physical activity if you're up for that. That also includes eating a healthy diet, rich in nuts, fruit, vegetables and whole foods, and getting a good night's sleep each night of at least 7 hours if we can achieve that.
Okay, so I guess the usual things. And what else did the scientists find here?
Yeah, so these researchers from the University of Maryland looked at MRI brain imaging data collected from 19,000 people aged between 40 and 69. And that's again from the UK Biobank.
Such a powerful data set, that one, isn't it? We're learning so much. Sorry, go on.
Yeah, it's really great. And in particular, they focused on white matter of the brain.
Okay, and what was that? What's white matter again?
So white matter is like a network of nerve fibres that connect different brain regions to each other. And we know they're crucial in things like learning and memory. White matter has also been linked to impaired cognition when it changes in structure as we age. So the scientists looked at data from surveys in which participants reported on how well they followed the 8 healthy habits, with these responses scored on a scale of 0 to 100. And a larger score essentially means that people more closely followed those healthy habits. And they did some analysis, and essentially they found that for every 10-point increase in that survey score, the AI model predicted that a person's white matter was 113 days younger, even when accounting for factors that might affect those results, like people's sex, physical activity levels, and whether they had brain or heart conditions. But again, as in the other study we spoke about, a caveat is that the participants were mainly white and of European ancestry.
So more reasons to, eat and sleep, get your good sleep hygiene, eat well, do exercise, even if it does feel like a bit too much effort sometimes.
Yeah, making these healthy choices is obviously very important. I did speak to Claudia Suamoto about this, and she's a physician trained in geriatrics at the University of Sao Paulo. And she said the study should also give policymakers in government and in the food industry another reason to really create environments that make it easier for us to make those healthy choices, whether it's stacking healthier foods closer to eye level in supermarkets, or adding more health warnings to unhealthy foods, or even just making a neighbourhood nicer to go out and walk or run in.
I think that's so important, isn't it? Often we jump straight to like labels on food, but if that's the only food available or the only food that's affordable, that doesn't really make much difference, does it? And every now and then I read a study about making cities more livable, and it sounds amazing. So things that make it easier to actually get outside and do these things would be fantastic.
I mean, I'm thinking grander. I'd like to be in the bit of the multiverse where you can eat whatever you like and not get any sleep, and it's really, really good for you.
I'm sure someone will claim seeing that Ozempic will do that for you, Jacob. Right. Before we go this week, I thought we could just talk about our beautiful Christmas and holiday issue, which is just coming out and hitting shops at the moment. Yeah, there's so much in it. Rowan, you've got an amazing bit where you imagine a future, which is one of my favourite ideas ever, is that we could hibernate like bears and just skip the worst of the season.
Yeah, I've also wondered about hibernation before, and there are different mammals do it in different ways, and apparently we should do it the bear way, not the squirrel way.
Yeah,
but you can find out why in this story.
Fine. There's also like an incredibly amazing word search in here. It's mind-boggling.
Yeah. Another one I liked is a nice time travel story. Always good for chewing over after your Christmas lunch, basically.
And Jacob, you've got the news team did a whole review of everything notable of the year, right?
Yeah, we've looked at everything that's been going on from, the worst of climate change, what Elon Musk's been up to in various different ways, from SpaceX to Neuralink. And we've also got the science of why believing in Santa is not all that you think it might be.
Oh, that's very intriguing. So that's in shops now, but you can also read it in our app. All of the stories are on our website, newscientist.com. We hope you enjoy it.
Yes. So that's all for this week. Thanks to all our guests. Thanks to you for listening. Do, as always, tell your friends about our show. Give us a 5-star rating on Spotify, Apple and all of that. And we'll be back next week.
Bye.
Bye for now.